Well, Marcus is still looking at doing things with money, and now he wants to save $250,000 towards his first house. He finds an account with an APR of 7.5% compounded monthly. 7.5%, that's got to be our rate. Compounded monthly, that tells me that the N is 12. The 250,000 is what he wants to have saved. This guy's got so much money. I want to get to know him. This is not his payment. This is not what he's putting away each month. This is what he wants to end up with. So this is his future value. How much will Marcus need to invest each month? So we're trying to find what is the payment for 10 years is how long he's thinking he should save up. So his T is going to be 10. All right, so now we have all the information we need for this formula. It is solved for the payment in terms of future value, and it's just the upside down of what we had before, right? 1 plus r over n to the nt power minus 1. Yep, so just upside down from what we had before, and then it's solved for payment instead of future value. So I can plug in all the things we know. The future value that he wants is the 250,000, and he's going to have r over n, which is 0.075, and our n is 12. We're definitely going to want to use store and recall for this one. And then we have 1 plus r over n again, 0.075 over 12 to the nt power 12 times 10 minus 1. So I want to take that 0.075 divided by 12 and get it onto my calculator. 0.075 divided by 12. 0.00625. I'll store that just so we can have practice seeing that. Store in A. So it's going to overwrite the 0.005 from my last problem. And there it is sitting on my calculator. So I just want to write on my problem that I stored that in A so that I don't forget. And I want to write somewhere 0.00625. so that I have a record of what I came up with. So if I make a mistake or I want to rework, I can check myself as I go. This we also stored in A. So now I have the 12 times 10 over here. I know that one. If I didn't, I could just say 12 times 10, and that gives me the 120. And now things look really messy, so I just want to rewrite. Call me anal. There we go. And so then I have parentheses 1 plus a raised to the 1/20th minus 1. Now things look ready for me to calculate. So I do want to calculate this denominator first, starting inside the parentheses. So I'm going to say 1 plus recall a, because I stored it in A, equals, and I have 1.00625. I have to take that to the 120th, and I get 2.1120, etc. And I'll just subtract 1 from that, and I end up with, let's write this down, we're down to just almost nothing here. So I'm writing that down. It's sitting on my calculator. I need to take what's in A divided by what's here. I have a couple of options. It depends how brave you feel. If you want, you can store this in B or another bin, and then just do recall A divided by recall B. That's an easy way to do it. Or you can remember this is being stored already in ANS, the answer button. And so I can just do recall A divided by answer, and I get my result of 0.00562, etc. And then the last thing to do here is to multiply by $250,000. So Marcus needs to deposit $1,405.04 each month to get to his goal of $250,000 for a down payment on a house. Now, if that was me, that would be the total price of the house, not just a down payment, but Marcus probably has a little more money. So question number 2, we are always wondering how much is he actually depositing and how much is interest. And so that's what question 2 and 3 are dealing with. Question 2, how much will Marcus have actually contributed to his house? And so for this one, it's going to be that same formula that I gave you that you have to memorize if you want to use, or you can just think about it, but we need to take his payment times the number of actual payments that he's going to make. And so for him, that we just calculated the payment, we want to use it in its rounded form because he's not going to deposit fractions of a penny. He can't. He can only deposit the actual 1405.04. So we'll take that times his N times T. N was 12 because it was a monthly deal, and T was 10 for 10 years. So we can do 1405.04 times 12 times 10. And if he's making 1,400 deposits each month for 10 years, he will have deposited $168,604.80. So that's how much Marcus is saving. And then we want to know how much interest did he earn from the bank. So we take the future value minus his contribution, same as the last problem, and that's going to be 250,000 minus 168,604.80. And since I already have that $168,604.80 on my calculator, I will just do 250,000 minus answer and find out that he actually earned $81,395.20 in interest. That's a ton of money.